Okay. Now we'll come back to renewable and sustainable energy. This is week number 12, module number 4. This week we are going to talk about two topics. These are the energy conservation and the geothermal energy. I will start with energy conservation. Simply, energy conservation is we use energy to do some functions, to produce something. We are looking to produce the same function, the same activity, but with less energy. I mean, saving energy. So conservation, how we can do the same job, the same task with this energy. This is what we looking. Definitely, this is related to energy efficiency, and there are many reasons behind this. It could be financial capital we want to increase, or environmental impact we want to reduce, or national security, or personal security, or human comfort. So many reasons behind this. But can say most people today look into the financial situation. How can, as example, today the incentive reduced for electricity, so the governmental subsidy reduced. So everybody start concerning about energy. They start using it in better way, in efficient way. And in the past, you may sit in a room here. I'm talking about the habits and attitude of people. They sit in a room, but you can see 2, 3 air condition in the house working and nobody there. Now today, most of people start considering this because they know that they, at the end of the day or the end of the month, let me say, the bill will be high. So they need to take energy conservation in consideration. This is to be done by persons, in small, let me say, house, or let me say in a community, small community, or in a cities, or in a companies, in industrial companies, as example. They start looking how they can reduce the energy, let me say, consumption and save it. And this take me to sustainable energy. You remember I talk about sustainability, and we link the sustainability, if you remember, at the early in this semester, with how we can manage our tasks and activities in this world, but without compromising the future, let me say, generation resources. I mean, how can we do this to sustain on this planet? Now, how can we put sustainable with energy together to make sustainable energy? How can we make our energy sustainable? I put here 3 important corners for the triangle. These are the conservation. Everybody should be involved in conservation. People, population, communities, organizations, companies, manufacturer, everybody. The second issue is how we improve the efficiency. I mean, reduce the losses. How can we reduce the losses? People are working on this, from small devices to large systems. And the third issue is renewable energy. How we can invest in renewable energy, because renewable energy here, let me say, we waive the losses. Losses isn't anymore an issue. It is not the main issue. It's an issue, but it's not the main issue, similar to fossil fuel. Besides, there are many incentives and feed-in tariffs everywhere in the world for different countries. Sorry. Now, I'm with introduction for the energy conservation, and it's worth to mention that U.S. I will take example here. U.S. In this introduction, U.S. represent 5% of the world population, but their consumption is 26 of the world energy. What this tell me? This tell me their share from the cake is higher than weight, right? Their weightage is supposed to be 5%, so their energy consumption is supposed to be 5%, but they consume 26%. 12,000 kilowatt hour electricity consumed by person in US, and this is 9 times the world average. Okay, this is reflected on carbon dioxide emission and so on. But from the other side, there are many people who have no access to electricity. It's in 2010, it's around 2 billion people. So these need to be, let me say, try to be neutralized and make it a flattened curve rather than spikes. Now you may say, okay, this energy, where it's consumed in different parts of the activities. But let me give here example about energy conservation, energy consumption from few, let me say, Texas, Ontario, California, and Northern. You can see some of them high consumption. This is in kilowatt hour per year, and some of them low, and some of them in the middle. Okay, as example, these. So location, where is your location? Specify how much your consumption will be. As example, if you, and the type of consumption. Example about the type of consumption, let's take Ontario. Ontario is a cold, it's the north, and then they need heating. So if I break down this 10,000 kilowatt hour, I break it down, I will find that they use around 57 to 62% for heating, space heating. And for water heating, they use around 21. The remaining is appliances, lighting, cool. So mainly here, 80% they use for heating. Why? Because it's cold place. It's in the north, snowing most of the time. So their consumption mainly here in these two categories. This is the cost of each category, because at the end, our energy consumption translated into cost. So if we know how to conserve energy here in this sector and this sector, in this category and this category, how we reduce the consumption, this will reflect here and here, the cost for this. This is what we are looking for, is to save energy, to reduce energy, and at the same time do our function correctly. Another example is California. This is the breakdown of energy consumption in California. You can see here 22 lighting, 19 refrigeration and freezing, TV and other equipment 15, and the other here you can see, you can read here from this pie chart different applications and their percentage of energy consumption. Now we need always to focus, mainly focus on the highest part of the consumption. Any difference we make here reflect on our consumption, on our cost, the cost we pay for the bill at the end of the day. So if, as example, this part I save it, I reduce it, as example, to 90, 3% I saved. This is translate as income back to me, not outcome coming from a wallet. Now, also the type of, let me say, I talk about Ontario, and they use most of their energy consumption for heating, heating, water heating. How can we heat? There are different technology. Example, we have here geothermal heat. I will talk about it, inshallah, the second session. Natural gas, electric heating, fuel oil heating, pipeline, and water. So we have different methods. Each method have its cost. Sometimes it's low cost, sometimes it's middle, sometimes high cost. So what are the options we have? We need to look. We consider the cost also. So we have different options. We need to consider them. Having one option is not right. I mean, I remember 20 years back, it was only for communication. It was only Omantel, right? Today we have Shell, Ariba, and maybe other companies. This is good. The diversity is good. Also, 20 years back, we're talking about only fossil fuel to generate electricity. Today, you know, the situation starts to be changed. So diversity is important. Look to the option and try to make diversity and select the best. Now, still with introduction, if I want to deal with energy conservation, I need to know the load profile or the energy profile of my applications or my example. If I look here, let's assume I have house. I need to come and list the applications, let me say appliances or applications, my application, what I'm using energy for. I'm using for clothes, dryer, washer, computer, food, microwave, stove, air condition. Okay, I list them in my house. Then what is their wattages? How much power, what power they consume? As example, this is consume different value, as you see here. What is their annual use? Annual use, it means how many hours per day, how many days per week, or let me say a year at the end. So I try here to find what is the annual usage, okay? And then cost. And I focus on the high cost. Small cost difference is good, but it's not good enough because it's not appear enough. But it's visualized for the large consumption. The cost will be reduced. I mentioned for US and their energy consumption is high because of their lifestyle. If we come to Oman, Oman is higher than US consumption. Why? Mainly because of air condition. Air condition consumption is high. Now you may say, okay, how can I conserve energy? We can conserve it using different technique, different methods. But here I would like to give some tips about energy conservation as examples. By the way, this topic, I mean, it's not enough to cover in one session. I need maybe 5, 6 sessions to give more details and more. And it's really interesting this part because it's related to our life, to our bills, and so. And some of them you will find easy to be let me say tested, because it's not. I mean, something we can do it. Let me give example about how we save energy. Example, you know, let's assume you have air condition working in a room. There is difference between the situation when you open the window and the door and air condition and close them. Why? Because you save the energy inside, the cooling inside. Air condition will be not working for some time until it gets heated and back to work. But if you keep the window and the door open, it will work 24 hours, may consume 24 hours. So this is how we can do it. Let's make the air tightness, let the use, or let me say close the leakage in the building, in the rooms, so to make sure that we save the cooling. If it is cooling, we save the heat is the heating. Also, type of appliances we are using. As example, washing machine. Some people using front load washing machine, washer or washing machine, or some of them use top loading washer machine. Okay, the front reduce the electricity and water by 50% compared with the other one. So type of equipment you use. A programmable thermostat. You know that the air condition, the old technology is using thermostat, which is a sensor, sense temperature, and based on this, it's connected to switch to be on or off the air condition. And when it's on and off, the air condition consumes a huge amount of power and energy. To reduce this on and off, what we do, we use a programmable thermostat. Programmable thermostat will not go on and off. It will only reduce the consumption and increase based on the temperature. In this way, we save energy. Using microwave better than using oven, electrical oven, okay, or heater. Using laptop better than using, let me say, PC, personal computer. As you can see here, I mentioned here to the percentage of power losses less, I mean, if we use this application. And some applications or some equipment we purchase from the supermarkets, as example, we find with them there is energy stars like this. Okay, 2, 3 stars. This is tell you that this is less energy consumption. This is conservative energy, let me say, devices. Using a plasma monitor, or let me say TV, or using LCD. Look which one is consume less. And plasma it's consume around 500, in the range of 500 watt. When it is standby, it consumes 75 watt. Okay, and this is take me to tell you something about your habits. Habits is important part, need to be considered. Now, people here, as example, in this region, the Middle East in general, when they go to purchase any device, as example, you want to purchase receiver, okay, for your to watch TV, and so you look to the brand, to the shape, to the type, to the color, to the price, but nobody look to the wattages. Nobody look to the wattages, how much its consumption. They don't care about the consumption, while it's work for many hours through the day and days through the year. So the consumption will be high. They don't look to this. This need to be changed. We need to look to how much the energy of the applications we are using. In Oman, as example, we have here, we use electrical water heater in our homes to take shower. You use electrical water heater, and this is because electricity in the past it was cheap. Now it's become expensive. Okay, we need to consider this. We need to consider changing to the other alternative or other options. As example, in the region, if we go to the north part of Arab countries, Syria, Lebanon, Palestine, Egypt and other countries. Or if you look to Turkey or Iran, they're nearby. They use solar heater, solar water heater. Why? Because it's nature. It's coming from nature. The cost will be low. It will not reflect on the bill at the end of the month. So why don't we use this technology? And this is cheap. It's not expensive. This is from Sohara University on our building solar water heater. And many countries, as example, Greece, Japan, they make it the main type of water heater. Also, US, other countries, and not only reflected on consumption or on the bill, also it's reflected on the environment where it reduces the carbon dioxide emission. Now, research and development is going on to reduce the cost, to make it better and better and more competitive with other options. We talk about solar water heater. You remember we discussed this type of systems, and it's easy to manufacture everywhere in the world. It's not big issue. It's not big technology. Or we can use vacuum tube as we discussed before. This is for heating. For cooling, we can use solar air conditioner. As you can see here, it's available in the market in Oman today. Okay, and it's working according to the solar-driven thermal system. I discussed this before, but just to remind you, we use heat coming from solar energy to create cooling by thermal-driven cooling process, and then we cool. These systems are available in the market. Also, we can use, as I mentioned before, the solar photovoltaic to provide energy for the houses, and solar thermal to provide the required heat for the houses. 2 in 1, or hybrid, as I mentioned, solar photovoltaic thermal systems, hybrid systems. In this way, we use renewable energy for energy conservation rather than we use energy coming from the fossil fuel burning. Also, I mentioned that our students manufacture these systems in the lab, the workshop, different system, solar water heater here, solar water desalination here, concentrated solar power here, and other systems. Sometimes we can't let renewable energy for energy conservation. We let renewable energy participate somehow with other sources of energy. As example, for tankless water heaters, sometimes we don't need to save the water heater in tank, hot water in tanks. We can use it directly by heating it. And it's happened by hybrid system. Hybrid system, it means we use solar with natural gas at the same time. We use solar with electrical heater. It's happened, as example, in this hybrid system, it's used widely there in Australia. In Australia, they use this one, and it's effective and it's efficient. Also, the insulators we use in our houses and building. Now, many people, when they build their houses, they don't consider insulation because it's extra amount they need to pay, even if it is not much. But anything they can cut, they cut it, which is wrong because this insulator will recover itself very fast. Okay, you return your money very fast because it will reflect on the cooling inside their houses, but they don't consider it. And we can know what type of insulator and material we are using, okay, from this formula, which say that the heat over the thickness equal to the area of the surface temperature difference divided by the thermal resistance. By the way, thermal resistance similar to electrical resistance in Ohm's law. And maybe here in Oman, as example, I didn't see any regulation to organize this. But let's take example from US. US in the Federal Housing Administration, they make a regulation. As example, for ceiling, they put this thermal resistance they should be. For walls, they put this. For floors, they put this thermal resistance. I give example about not only thermal resistance, but also about air conditioning, how we cool the houses or building. The regulation in US, as example, what they do, they look to your location. What type of weather in your location? Is it warm? Is it cold? It is humid? It is dry? As example, you can see here, they put them in 3 categories. Okay, as you can see here, cold, mixed, warm. And you can see here in these examples, some states fail in this category. As example, Los Angeles, South Los Angeles, and so. And some of them here, New York or Arizona, and some of them here is depend on the weather and the location. And they make in the regulation as example for warm weather or mixed weather or cold weather, you have different way for air conditioning. As example here, gas, oil, or heat pump, geothermal heat pump. I will talk about it inshallah next session. Or electrical resistance, mean electrical heater. And so the type of system they specified, it's not, there is no regulation in the region to specify. You can put whatever you want, electrical, whatever, anything. But there they have regulation. For sealing, the thermal resistance need to, by the way, when we say need to specify here, as example, R11 to R13, the thermal resistance, this is reflected on the type of insulator you are using. Okay, and this is good because imagine, imagine without insulator in summer here in Oman, okay, since we are at home, we use the air conditioning 24 hours. We cannot switch it off. I remember years back, I gave advices for many people start to build either their houses or they're building, some of them are building shopping centers, and so the advice I gave for them is use insulator in your building. It will reflect sharp and clearly and significantly on the air conditioning. And the feedback I received later, one of the consumers, he said that rather than I use for my house, as example, 24 hours in the past, the new house, when I put insulator, I use the air condition only for 4 to 5 hours daily, because the remaining time it's automatically switched off because the cooling contaminated inside the house because of the insulator. No heating coming from outside. The weather inside the house will be good enough to switch off the air condition. So insulator is important, we need to consider. This is load profile for typical house, small house for 2 persons as example, or 2 or 3 persons. You can see here, you can apply this to your home. Make a table similar to this. See how many fluorescent lamp, light, refrigerator, how many television, let me say if you have air condition. Less depth, this is the quantity. The example could be 6, 7, whatever it is. Forget about the voltage, but look here to the wattages. How much the consumption, the watt power consumption for each one of them. As example here, 1000, which is the highest air condition. Okay. How many hours a day it work? Is it 5, 24 hours, 1 hour, less, more? How many days per week? Is it 7 weeks, 7 days a week, 3 days, more, less? And then you can multiply, forget about the search, but look here to the average watt hour per day, the energy, the daily energy consumption. When I put, I multiply and find this, and divide and find this. When we do this, we found that where is the highest consumption will be? Oh, air conditioning. So my focus will be here. How can I reduce this amount? Because it represents around 93% of my consumption. Any change here will be reflected positively on energy conservation, positively on the bill. The bill will be reduced, and everybody will be happy. Now here my advice is for our approaches, let me say, to save energy in Oman, what we should do. Okay, as I mentioned, usually I give this as a workshop and it take a few hours, but today I will, because I have limited time, I will just give tips here and try to make it as much as brief. We need to reduce, we need to reuse, we need to recycle. Apply this for whatever we have at home, right? This will lead to effective conservation or for energy. Energy audit. Energy audit, mainly today, people are doing energy audit for organizations or companies. They try to study their energy load profile, and they focus on the high loads, and they try to reduce it, what we call best bits. Try to reduce take the better scenario. How we can run our company in the same situation, if not better, but with less energy consumption. Where is the wastage? Where is the losses in our energy? Now let's apply this also to our homes. Our houses need to consider this also. Energy calculator. Calculator, we come buy a calculator and put it. It's not necessary to only to monitor the meter, the meters which measure the energy, but also to calculate them to see at the end how much you will pay. Don't wait for the bill to come to you. You need to know the bill in advance and to manage your consumption. Make a plan, set goals, let everybody involved in this. We need to encourage our sons, our brothers, people living with us about how they use, as example, how they use the energy. As example, we teach our sons, okay, the young of the new generation, to brush their teeth. Okay, this is our duty to train them. But we need to train them also something else. As example, how they save energy. Okay, we need to tell them that when you leave your room, please switch off the air condition, switch off the light. This is waste. Okay, and how this will reflect on the bill, how this reflect on the planet. Make it something bigger for the kids and for the people living with you. Combine heat and power. Try to use equipment that that represent 2-in-1, 3-in-1, 4-in-1. As example, they give heat and power at the same time. Okay, you remember I talk about hybrid PVT, photovoltaic thermal. It's give heat and electricity at the same. Look to these type of equipment. Renewable energy incentive. If in your country there is incentive for renewable energy, as example in Oman there is incentive for solar energy, even if it is low, but still there is incentive. Try to look how to use it. Okay, invest in this, because there is regulation. You can put on your rooftop, let me say PV, and connect to the grid, and then sell electricity you generate will reflect on your bill. Convert type of lighting. Now, many people until today, they use incandescent light bulb. This use, let me say 100 watt per bulb or 80 watt, which is all days. It's from, let me say, Edison time. Until today, you're supposed not to use it. Okay, or they use the fluorescent lamp. Okay, these are, let me say, energy consumption lighting. Go for LED as example. LED use less. Okay, it will save a lot. Many electrical companies in Oman, they start feeling this in the last couple of years, and what they did, they changed the lighting for the streets because they found that it will consume less energy and reflected on their consumptions. And as I mentioned, we need to educate people. We need to involve everybody. We need to change our habits, our mentality regarding how we use energy. I will give here example about lighting in Sohar University. Okay, I got this information from related to the department about the lights used in Sohar University in different buildings, in the parks, and also their consumptions, their number and their consumptions. Okay, and here I start to do simple calculation. This calculation give you an idea. Have a look. They have, when I did this study, this is in 2015, up to 2015. They have 9,347 lamps. Their rating range between 60 watt to 100 watt. Okay, for each one. So let's assume in average it is 80 watt. And you know the day is 24 hours. Let's assume the light will work for 12 hours only at night. And let's assume that, and multiply it by 365 days a year, then the energy consumption will be this amount. Let's assume that for each kilowatt hour, 10 paise in the past. Today is higher than this. But let's assume it is 10 paise only. Okay, so if I multiply 10 paise by this amount here, it gives me how much energy, how much money I pay for electricity in Sohar University annually, every year. It's in the range of 32,000 Omani Riyal only for lighting. Okay, now for energy conservation, what we will do, rather than we use 80 watt, we will use 40 watt LED. and it gives the same effect. But see what I did. I cut my bill to the half. Rather than 32,000 Omani Riyal yearly, it will be 16,000 something Omani Riyal yearly. Let's take another scenario. We reduce it to 20 watt. The bill go down more. So this is what we are talking about. We get the same effect, the same function, the same task, the same work, but with less energy. There is scenarios, there are many scenarios, okay? But we just need to study them. We need to make energy audit and to know where to do action. Okay. Now, energy conservation measure, or what we call it ECM, what they did, they tried to categorize the applications for energy applications in 6 categories and measure them, and based on this they take action to conserve energy. These categories, the 6 categories, are energy consumption in architecture, in heating and cooling, domestic hot water, lighting, miscellaneous, additional ECM. Additional one is when we cannot put the application in one of the previous categories, we put it here. And before I talk about these and give an idea, I would like to define 2 important parameters related to the cost, okay, to the economy. The first one is the payback period. Payback period, it means how long it takes to return your investment. As example, I invest in a project. It cost me 1,000 Riyal. It took from me 3 years to return the 1,000 Riyal. After these 3 years, anything coming, any income will be revenue, will be benefit. You got it? So I'm looking to this 3 years. So payback period is the lowest time to return your investment. Now, cost effectiveness. Okay. What is the payback which represents the critical between a succeed project or failed project? Up to what, how many years I need to return my investment and I say it's okay, it's fine. Okay. This is what we call it cost effective. It means the cost is effective for my project. Now they put 15 years for the latest or the worst cost effective. It means below 15 years is good. After 15 years is not good enough. Now, for the energy conservation measures, EMC, as I mentioned, ECM, I mentioned that we have 6 categories. Let me start with the first one. You can see here architecture. By the way, I took here just example. Otherwise, the list is large. It's not enough. It's not only from 1 to 8, as you can see here. No, there are many. Example, okay, is we put insulator, as I mentioned. You remember when we put insulator, this is part of the architecture, and when we put insulator, we reduce the energy consumption in the building. We use, as example, window with double glazing, vacuum between them. In this way, we get light, we reject heat. We don't need heat here. It's already hot, warm weather. So we want the light, natural lighting on the day, but we don't heat to come inside. Vacuum, let me say 2 glazing, but vacuum between them will be a good option. Or let me say I use better lighting, or let me say I use shadow or window for the windows, umbrella, so it reduces the thermal energy coming inside the houses. For heating and cooling, let's use solar water heater, domestic solar water heater. Let's use PVT. Let's use thermal driven air conditioner and so on. Okay. Domestic hot water, as I mentioned, we can use install domestic water of peak controlled one, and use in the peak, on the peak. Okay. We contaminate the tank for the hot water to make sure that more energy will be saved. For lighting, as I mentioned, we can use reflectors to increase the lighting and reduce the electricity consumption, and so on. Here I listed, okay, you can read them later on, but I listed here some point to clarify what is the lighting system, what is the domestic hot or water system, And other let me say activities which is not in lighting part or air conditioning and thermal system and can be listed here in the miscellaneous as example. We replace the inefficient motors. Some equipments when it get aging happen to it, okay, it's consume more energy. As example, motor for a conveyor or for air conditioner, because these their winding will be burned with time and their resistance will increase, the consumption will increase, okay, so it's better to replace them and so on. Now I will stop here with the life cycle cost. Life cycle cost and life cycle analysis and geothermal to be discussed in this, because here we have calculations, we have formula, we need to spend some time on them. And I think I will stop here for energy conservation. There's a lot of to say here. Actually, this is one of the interested points I always enjoy when I talk about them. But as you know, we have limited time, so I will stop here. Now, do you have any question before